Assalamualaikum warahmatullahi wabarakatuh. My name is Zulaikha Shazreena binti Zakaria, B012-210-161. Okay, our group project will explain about microprocessor controller, server segment, display and switch using MC68000.
Assalamualaikum and good afternoon. My name is Fathiah binti Saharudin and I am going to explain about introduction for Motorola 68000. Motorola 68000 is a microprocessor that often referred to as the MC68000, is a 16/32-bit, became one of the most popular and influential CPUs of its time, laying the foundation for the development of modern computing system. There are several key features for the Motorola 68000. Okay, firstly is a 16/32-bit architecture, which is the 68000 microprocessor has a 16-bit data bus and 24-bit address bus, but internally operates with 32-bit register. This hybrid approach allowed it to perform more advanced operation than purely 16-bit processor while fitting within the technological constraint of the time. Secondly, its instruction set. 68000 has a rich and versatile instruction set that includes a variety of data, manipulation, and control instruction, making it capable of handling complex tasks efficiently. Thirdly, its memory management. It supports a large addressable memory space, which is 16 MB due to its 24-bit address bus, which was significant for the system of that era. Lastly, its peripheral compatibility. The 68000 could be easily interfaced with existing Motorola peripheral chips designed for its processor, the 68000 series, which helped in its rapid adoption. This project aims to design a system that can control 7-segment LED that produce bus response to input and output signal given by the MC68000. There are 3 objectives in this project, which is to create 7-segment LED to display bus when triggered by switch in microprocessor 68000. Secondly, to stimulate switch and 7-segment LED based on the given input. Thirdly, to assemble and demonstrate project using IDE 68K. The MC68000 has been used in the indicator system for the manageable and controllable operations of the buzzer and LEDs based on real-time inputs and predefined condition, which is hardware component. For hardware component, there are a few item in the hardware component, which is MC68000 microprocessor, which is a powerful and versatile microprocessor that can handle complex control tasks. Secondly, switch and 7-segment LED. The 7-segment LED used in the project to produce bus word displayed on the 7-segment LED to replicate the buzzer that used in the system, which are also interfaced with the microprocessor through the peripheral integrated circuit. The last thing is the power supply unit, which is a regulated power supply unit, provides sufficient voltage and current to the microprocessor and all its connected peripherals to enable them to function properly.
Assalamualaikum and a very good morning. My name is Mohd and today I will present about our project on how it's work and the simulation of it. First of all, when the program runs, the toggle switch 0 will wait until the state change. After the state change, the 7-segment display will display buzzword and LED 0 will light up. After that, it will wait again until it state change. After the state change, the 7-segment display and LED will turn off. Then the program will always loop until the exit button click. So now let's move on to our program. So this is our program. This command here is to initialize the toggle switch. This one here is to initialize the 7-segment display. This one is for clearing the display. This is one for clear the loop. This is the main loop, which is this 2 line here, is to read the state or status of toggle switch. This one here will display buzzword when the toggle switch is set or 1. This one here will clearing the 7-segment display if the toggle switch is clear or 0. So now let's move on to the command here. This is the command to display the BUZZ word, and this one here is to turn on LED 0. So I will explain only this line. This line is actually B word. So if you can look here, this is the 1111100. So if we look here, only the rightmost 2 will be 0. So it's mean that A and B will be 0 and other will turn on, which mean it will give us the B word. We also have another approach, which is here 7C. If we convert 7C to binary, it will give the same value, which is 1111100. It is same like our first code, which is here. It is will display B word And now this line here will make the display turn off or go blank, because the 00 here, if we convert to binary, we'll give the 00000, which is all of it will turn off. So let's move on to our simulation. So let's start the simulation. So now let's look at the hardware. So now after I start this button, the buzzer and LED will turn on. Then after I turn off this toggle switch here, the LED and the 7 segment display will turn off. And then it will always loop until the exit button click. So I think that's all from me. Thank you.
Thank you, Asyraf, for the explanation. Now we will move to the discussion. In this discussion, we divided our discussion into 5 branch, where this 5 branch explain about the content of our coding. So the first branch start with initialization, where the code start with move B instruction, which is likely to move data between the register. And during initialization, there is instructions such as move LD1 to A0 and move LD1 to A4, which is to load data from the data register D1 into address register A0 and A4. And finally, the final instruction in initialization is to setting up for a loop counter. For the second part of the discussion is about the clear display and clear loop branch, where the clear display branch is used to clear the content on the display or memory location. There is certain instructions such as LIA, move Q and move B, which is instruction used for loading data and clearing register. And in the clear loop branch, it is about a loop that continues for a specific number of iteration. The instruction include in clear loop move W, move B, add Q.W, sub Q, which are instruction typically used for moving data, adding data, subtracting values, and for branching. For the third branch, it is about a main loop branch. The instruction move B is to move a byte of data from one location to another location, and the other instruction that include in this branch is a bit test loop, where the code is currently test for the value of 0 in D2, and there is 2 additional instruction, which is BNE.S and BRA.S, which is when the switch is triggered, it will directly go to the display buzzing branch, and if the switch is currently in 0, it will go to clear display branch. For the fourth branch of our discussion is we are going to talk about the display buzzing branch, where the instruction begin with move Q #0 D1 and move Q #1 D1, which is to set the value in the register D1 to 0 and 1 respectively. And as you can see in this code, there is a lot of BCR segment 7, which is a subroutine that is named segment 7 to control the 7 segment display based on the value in register D1. And the other instruction, which is bra.s main loop, likely jump back to the beginning of a loop named main loop. For the last branch, which is the 5th branch of our discussion, is about the segment 7 branch and digit branch. For segment 7 branch, it is a subroutine that translate an index into a segment pattern and update the display accordingly. And for the digit branch, it is a digit branch that contains 8 bytes of data. This data is likely used to control the 7 segment display 0 to 7 and represent the pattern to be displayed on the 7 segment display itself.
This project showcases the application of a MC68000 microprocessor in a system controlled by a 7 segment, demonstrating its efficiency and responsiveness in various industries. The system uses a toggle switch, a 7 segment display, and interfacing component, with a microprocessor acting as a central control unit. The system has high instant response accuracy and reliability, making it suitable for various fields. Feature improvement including addition input, PWM implementation, power management, and advanced input condition logic. Okay, for recommendation, I recommend we add more input to trigger the 7 segment. So it can increase flexibility in the system, like making it trigger under several conditions. Second, implement path with modulation PWM, so it will make the precision of the control with output device become far better. Third, adding power management. So if we add power management filter, it can optimize energy consumption using sleep mode or power saving technique. Lastly, implement more advanced logic for input condition. So it will increase the system communication capability and interfacing with the user become far better.